Low pass band pass filtering lecture part, a topic under unit number 3, mathematical representation of noise. First of all, let us go for an ideal low pass filter. We know that the transfer function of ideal low pass filter is given by the following equation, which is a standard equation of low pass filter. The input output power spectral densities are related as S0f is equal to mod of HF square SIF, where S0f is the output power spectral density and SIF is the input power spectral density. Since we have considered the noise to be a white Gaussian noise, therefore SIF will be fixed, that is N0 by 2. Substituting the values of SIF, we will get this equation. The average noise power at the output is given by P output noise is equal to integral output power spectral density. Substituting the values of output power spectral density from our equation and solving this integral, we get the output power noise as N0B, where B is the bandwidth. This equation gives the noise power at the output of low pass filter. Now let us go for an ideal band pass filter. The transfer function of an ideal band pass filter is shown in figure below. Again, to calculate the average noise power at the output, we are using the same formula. Output noise power is integration of output power spectral density. Substituting the values of output power spectral density and solving this integral, we get the equation as output noise power is equal to N0 by 2 into 2 F2 minus F1. Again, solving this, we will get N0 into F2 minus F1. If you look at the equation carefully, F2 minus F1 is again nothing but the bandwidth B. Now, let us look at the concept of noise equivalent bandwidth. Considering the transfer function of filter as shown in figure below, the passband of the filter is centered at F0. The passband of this filter is shown by dotted line. This is a real or practically realizable filter. Now let us prepare the ideal version of the filter. The passband of this filter is centered at F0 as shown by dotted red lines. The bandwidth Bn of ideal filter is adjusted such that the real filter and the ideal filter passes the same noise power at their output. Then the bandwidth Bn is called the noise bandwidth of ideal filter. Now let us calculate the noise bandwidth of RC filter. The noise power at the output of RC low pass filter, we have obtained it earlier and is given by equation number 6. We also obtain the noise power output of ideal low pass filter in this lecture only, which is given by Pn0 is equal to N0B for ideal low pass filter. By definition of noise band power, we know that the noise power at the output of real filter and ideal filter are the same. That is Bn is equal to B. Equating above two equation and calculating the Bn values, we get Bn is equal to pi Fc upon 2. This equation gives the noise bandwidth of RC low pass filter. Now let us move to the definition of narrowband noise. The signal of interest are usually passed through the filter and then given to the receiver. Such filter is narrowband and its mid-band frequency is large enough compared to bandwidth. That means if this is the filter, its mid-band frequency is F0. Say F0 is in some megahertz because we have already modulated the signal and the signal is in the receiver side. Now this bandwidth of this filter will be around say 10 kilohertz if we consider an example of EM stations. So if you compare 1 megahertz and 10 megahertz, 10 megahertz is relatively small as compared to 1 megahertz. The noise appearing at the output of such filter is called a narrowband noise. In order to illustrate this example, let us consider the following figure. In this figure, this noise is the channel noise which is input to this band pass filter. So this arrangement is a transmitter receiver system. On my left side we have the transmitter part, and on my right side we have the receiver part, a channel which connects these two systems. So most of the noise entered through the channel, and hence the channel noise, you can see it's a wideband noise. Now input to the receiver band pass filter is a wideband noise, but when the noise passes through the filter, say we are considering channel number 1. So when this wideband noise passes through this filter, band pass filter, the output of this band pass filter is nothing but a narrowband noise. Similarly, we can take the example for the NH channel. Again, before this NH channel, the noise is wideband noise, and after this, it becomes a narrowband noise. So this filtering system used to lower down the noise from wideband to a narrowband signal. So this completes this video lecture. Thanks for watching. Thanks again.